All right, next video, equations of motion, nicely underlined. So I've got a graph here. It's a VT graph. Just going to scroll down slightly. VT graph. Whatever this object is, it has an initial velocity. It's not starting from zero. Has initial velocity to start, and it starts to go faster and faster and faster until it reaches a speed VF. And that takes a time delta t. And we would say that this acceleration is uniform because this is a straight line. It's got a positive acceleration. It's getting bigger. And there are some things that I know about this, information I can get from this graph. So I know that the slope of the graph gives what? Oh, gives acceleration. Yes, which is rise over run. Yes, and how fast does it? What's the rise here? Well, it's VF minus VI over delta T. Yes. I'm going to box that guy in because he's one of the equations of motion that we will be using. And I'm going to call that guy equation number 1. All right. What information else can I get from a VT graph? From our last video, we know that the area under it, the graph, gives oh, time's up. Gives displacement. Yes. So what I'm going to do is I'm going to draw a little triangle plus a rectangle. And because I've got a triangle shape right here and I've got a rectangle shape. So the area of a triangle is 1/2 base times height. And the area of a rectangle, I'll use length times width. I'm going to get 1/2. The base of that triangle is delta t, and the height of that triangle is what? VF minus VI. Yes. Plus, I'm going to do this because I'm not sure that I have enough room to finish it in this little space. The rectangle, it's got a delta t is the base, and the height is VI. Now, if I do some simplifying, I expand this, I multiply 1/2 and delta t times this, and 1/2 delta t times that, and then I add that, I collect all the like terms, I'm going to get 1/2 VI plus VF delta t. And anytime I add two things together and divide by 2, that's usually how we get an average of two numbers. So I will simplify that one more time and say V average delta t. Displacement, put vector signs on there, and then I'm going to put a box around these separately. Sometimes it's easy to find the average V, and sometimes it's not. Okay? And I'm going to call this guy equation number 2. Good. And over here now, if I rearrange equation 1 from up there, yes, and you can go back and take a look, I get A delta T equals VF minus VI, and therefore VF is equal to VI plus AT. That's a nifty little formula. Makes sense if you look at it. The final velocity is going to be equal to the initial velocity plus how much I accelerate by and times how long I actually accelerate. This equation makes a little sense. The final velocity depends on what I start at and how fast I'm getting faster and how long I actually get faster for. I'm going to call this guy number 3. Don't really want it red, but you know that's just the way it is sometimes. So now if I sub 3 into 2 for VF, I'm going to go right up here and put it right here. Here's equation 2. I'm going to get D equals 1/2 bracket VI, yes, D equals 1/2 bracket VI plus VF, no, not VF, VI plus AT. Times delta T. And do that, and if I do some simplifying and collecting like terms, I will get that D equals VIT plus 1/2 AT squared. Another neat, useful formula. And I'm going to call that guy number 4. Yes. Now if I rearrange equation 1 from way up there at the top, I'm going to solve it for T. T equals VF minus VI over A. And I'm going to call this I'm going to call it equation number 5. I'm going to put a red box around it. Just trying to keep track of these equations. And now I'm going to sub 5 into number 2. Okay? So I'll go up here. Whoa. Up here and take a look. It's making a mess. Hold on. Okay. I'm going to take this equation right here. D equals 1/2 times VI plus VF times delta T. And instead of having delta T on the end, I'm going to stick in its place VF minus VI over A. So I'll write the first line. I'll get D equals 1/2 VI plus VF times delta T, and I'm going to replace that with 1/2 VI plus VF. Instead of writing delta T, I'm going to write this new equation 5 in its place. VF minus VI all over A. And it looks like a bit of a pig, and it is a bit, yes. I can simplify that to VI plus VF times VF minus VI all over 2A. Yes. These are all vectors. And if you've done some factoring work and I have something plus something, something minus something, that's called a difference of squares in math. factoring, and I can factor quickly, and I'm going to get, in the end, I get VF squared equals VI squared plus 2AD. Bing, 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 and bing. Okay? I will not ask you to derive these equations, but I do like to derive them and have you look, just so that they didn't drop down out of the page out of nowhere. Now, why are there so many equations? Well, look, this one has VF, VI, A, and D. This guy's got T, VF, VI, and A. This guy's got D, VI, T, and A. Yes. This guy's got VF, VI, A, and T. They all have different combinations of letters. So depending on what the question asks you and gives you, you need to pick the right equation for what you have and what you want to solve your question. Okay? There's a bunch of them here. That's the point of all of that. Oh, and there's the bell, and there's the end of the vid. See you later.